Hello everyone, this is our session 7 on trigonometric functions. We were doing exercise 3.2. We had finished the first 5 questions. We are going to the next question, that is question 6. Okay, so let us begin with question 6. Now, question 6 says that in triangle ABC, so it's exercise 3.2, question 6. Okay, so in triangle ABC, prove that a cube sine of b minus c, a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b is equal to 0. Okay, we have to prove this. So we will begin with first term over here. Okay, so what is the first term? We have a cube sine of b minus c. Okay, now we use the sine rule over here. So what do we have? So using the sine rule, okay, a upon sine a, okay, is equal to 2r, right? So we can take this as a is equal to 2r sine a, right? Therefore, a cube is equal to 2r sine a, the whole thing cube, right? So this we will substitute in our first part of the left hand side. Okay, so 2r sine a cube. So we write 2r sine a, the whole cube, multiplied by sine of b minus c. Okay, now what is 2r sine a whole cube? What we'll do is we'll split this. So one we'll write it as 2r the whole cube and sine a the whole cube, or sine cube a. Okay, sine of b minus c. Now we'll also split this sine term. Now how to split that? So we'll write this as 2r the whole cube, okay, sine square a, okay, sine a sine of b minus c. Yes, so now this 2 cube r cube can be split as 2r cube, 2 sine square a and 2 sine a sine of b minus c. I've just segregated this 2 to each of the terms. Okay, this and this. Okay, then 2r cube as it is. 2 sine square a can be written as 1 minus cos 2a. Okay, 2 sine a. Now 2 sine a can be written as sine of b plus c. How? That I'll show you just a minute. Sine of b minus c. So how do I get sine a equal to sine of b plus c? Okay, so I'll do this over here. Sine of a, okay, is equal to sine of pi minus b plus c, or another way would be a plus b plus c is equal to pi, right? 180 degrees. Therefore, a is equal to pi minus b plus c, right? And then you can do putting sign on each side. So sine of a is sine of pi minus. Now what is sine of 180 minus b plus c? It will be sine of b plus c. 180 minus theta, the angle remains the same. Trigonometric ratio remains the same. So sine A is equal to sine of b plus c. Okay, that is why instead of sine A, I have written sine of b plus c. Okay, and 2r cube as it is 1 minus cos 2a. That is 2 sine square a can be written as 1 minus cos 2a, and 2 sine a sine b minus c can be written like this. Now, what is 2 sine the ratio for? Addition of which two angles? So it is, we'll keep the first few two terms as it is, 1 minus cos 2a, right? And here it is 2 times cos of, sorry, not 2 times, only cos of 2c minus cos of 2b. Okay. From where do we get this formula now? Cos of 2c minus cos of 2b. I'm putting in the identity here in the bracket. So we have cos of a minus cos of b is equal to 2 sine a plus b by 2. Okay. Sine multiplied by sine a minus b by 2. Okay. So that will be cos, but this formula is with a negative sign. So we put a negative sign here. Now, if I wanted positive means what? I will have to write the negative angle as b minus a, right? So that is what I have taken in the uh, formula above, because we require a positive answer. 2 sine b plus c sine b minus c. 2 sine b plus c or c plus b, and then sine of b minus c. So b minus c, that is why we have cos of 2c minus cos of 2b. Okay, that will cancel out the minus sign. Now let's go to the next step. This will be 2r cube. Okay, we'll keep 2r cube as it is, put a square bracket. We'll multiply these two terms by these two terms. So we will get cos 2c, okay, minus cos 2b minus cos 2c cos 2a plus cos 2a cos 2b. Okay. Now this is the expansion of the first term, a cube sine b minus c. Similarly, we can write the expansions of the other two terms. Yes, so we can write b cube sine of c minus a as 2r cube, right, the first term. Then we have 2 sine square b, which can be written as 1 minus cos 2b, and then we have 2 sine b sine c minus a. Sine b can be written as again sine of a plus c, right? Similar, just exactly similar steps for this one. So you will get two brackets like this, 1 minus cos 2b and cos 2a minus cos 2c. We just multiply these two terms and write over here. So we'll have b cube sine b minus b cube sine c minus a equal to, we'll have 2r cube as it is, okay, and in the big bracket we will have cos 2a minus cos 2c, okay, the single terms, cos 2a minus cos 2c, okay, then minus cos 2b cos 2a, okay, and plus cos 2b cos 2c plus cos 2b cos 2c. Okay. Similarly, we can write for the third term, similarly, c cube sine of the question, c cube sine of a minus b. Okay. So sine of a minus b can be given by 2r cube, which then we'll have 2 sine square c, that is 1 minus cos 2c. Okay, and we'll have 2 sine c, sine a minus b, that is 2 sine of a plus b. Okay, sine of a minus b. Okay, so we'll write this as 2r cube 1 minus cos 2c, and use the double angle formula is here. 2 sine a plus b sine a minus b will be cos of 2b minus cos of 2a. Okay, and we'll multiply these terms. So we'll have 2r cube as it is. In the big bracket, we will have cos 2b minus cos 2a minus cos 2c cos 2b. Okay, plus cos 2c cos 2a. Okay, so this will be our third bracket. Now, if you will observe, each brackets we are going to add. Now, in each bracket, 2r cube is common. So, what I'll do is, I'll just write the left hand side, a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b is equal to, and then we write all the three terms that we found out by expansion. 2r cube is common for all of them. So let us begin with the first term. So what is the first term? 2r cube as it is, cos 2c minus cos 2b, cos 2c minus cos 2b. Okay, these are the first two terms. The next two terms, minus cos 2c 2a plus cos 2a 2b. So minus cos 2c cos 2a plus cos 2a cos 2b. Okay, this is your first term, a cube sine of b minus c. Okay, plus second term. So second term we have the expansion as 2r cube is common, cos 2a minus cos 2c, cos 2a minus cos 2c. Okay, minus cos 2b cos 2a minus cos 2b cos 2a. Okay, and plus cos 2b cos 2c. So we'll write this in the next line, plus cos 2b cos 2c. Just check it once. Yes. And the third addition, so this third last term over here, plus, what do we have? Cos 2b minus cos 2a, cos 2b minus cos 2a, okay, minus cos 2c cos 2b minus cos 2c cos 2b plus cos 2a cos 2c cos 2a cos 2c. Let us observe each of the terms. We have the opposite. So cos 2c, second, so cos 2c and minus cos 2c, so it cancels out. Then we have minus cos 2b, and do we have plus cos 2b anywhere? Yes, so we have plus cos 2b and minus cos 2b, which cancels out. Minus cos 2c 2a, we have 2c 2a. Yeah, over here, 2c 2a. So minus cos 2c minus cos 2c 2a plus cos 2a 2c. So we'll cancel it out. Then cos 2a cos 2b minus cos 2a cos 2b cancels out. Okay, then cos 2b and cos 2c minus cos 2b minus cos 2c. So this will cancel out here, right? These two are opposites. Then we are left with one term plus cos 2a and minus cos 2a over here, right? So there is nothing left in the bracket. So we'll have 2r cube multiplied by 0, which is equal to 0 equal to RHS. Okay, I hope this one was clear. We've used three formulas over here. First, we started with the sine rule. Then we've used sine square A, that is 1 minus cos 2c, sine square A, 1 minus cos 2a, sine square B, 1 minus cos 2b, and 2 sine square C, that is 1 minus cos 2c, right? And then we use 2 sine A plus B sine A minus B. Okay, so three formulas we have used over here. They are called as the factorization formulas, 2 sine A plus B sine A minus B. We've used those over here and found out the answer. Okay, first you get one term and the others follow, that is, they'll be similar to the first part. Okay, let us go to the next question. This is question 7. Okay, so what is question 7? It says that if in triangle ABC, cot A, cot B, and cot C are in AP, are in AP. Prove that A square, B square, and C square are in AP. You have to prove this. So let us begin. Now when we say cot A, cot B, and cot C are in AP, what do we mean? That their difference is same. That means difference of consecutive terms is same. So we write it as cot B minus cot A, okay, will be equal to cot C minus cot B, okay, which will give us the equation 2 cot B is equal to cot of A plus cot of C, okay, which can be written as 2 cos B upon sine B equal to cot A can be written as cos A upon sine A plus cot C can be written as cos C upon sine C. Now we'll make use of the sine rule as well as the cos rule. So how do we do that? We'll just write down the sine rule that we are going to use. So sine A is equal to Ka, sine B is equal to Kb, and sine C is equal to Kc. Again, for the cos rule, how will we use it? So we'll have B square plus C square minus A square upon 2Vc is equal to cos A. Okay. Then we have A square plus C square minus B square upon 2AC is equal to cos B, and B square plus A square minus C square upon 2AB is equal to cos of C. Okay, so these formulas we will substitute in this previous equation that we have. So 2 cos B upon sine B can be written as, we'll substitute cos B and sine B. Okay, so we are going to get cos B as 2 over a square plus c square minus b square upon 2ac. Okay, this is your cos upon sine B. Sine B will be what? Sine B is kb. So kb, okay, is equal to cot A and cot C. So what is cot A? Cos A upon sin A. Cos A can be written as B square plus C square minus A square upon 2BC. This is cos A upon sin A will be KA plus cot of C, right? Cot of C, yes. Cot of C will be cos C B square plus A square B square plus A square minus C square upon 2AB divided by KC, okay, for sin C. Now we'll take the LCM throughout. So here we have 2ACKB, 2ACKB and 2ACKB. So this can be written as 2 times A square plus C square minus B square. Okay. And we put a bigger bracket, put a division sign, and 2A, B, C, K is equal to B square plus C square minus A square upon 2A, B, C, K plus B square plus A square minus C square upon 2A, B, C, K. So this will cancel out throughout. Okay, we'll multiply the two inside. So we have 2A square plus 2C square minus 2B square equal to B square plus B square is 2B square plus C square and minus C square cancels out. Minus A square and plus A square also cancel out, right? So what do we have with us? We can take, or rather we should have left the 2 outside. It would have got cancelled only. Anyway, so we'll just take the 2b square here. So we have 2a square plus 2c square is equal to 4b square. Divide throughout by 2. So we will have a square plus c square is equal to 2b square. Okay, which proves that a square, b square and c square are an AP, right? If you have a confusion as to what is to be proved, how to write what is to be proved in the question, in the beginning only, we'll just make a note over here, okay, and write what is to be proved in simpler terms. We have to prove that they are in AP means what? B square minus A square is equal to C square minus B square, okay? Means the difference of consecutive terms should be equal. So we'll put b square here, we'll get 2b square is equal to a square plus c square. This is exactly what we proved just now, right? 2b square is equal to a square plus c square. So this is what we had to prove. I hope this is clear. Okay, this is question 7. Then, okay, so let us begin with the question 8, right? So question 8 is the 8th question. In triangle ABC, if cos A cos A is equal to B cos B, A cos A is equal to B cos B, prove that triangle ABC is right angled, okay, or it is isosceles. We have to prove this. So either one of the angles has to be 90 degrees or two angles have to be equal. So let us take what is given to us. A cos A is equal to B cos B. Okay, I'm using the sine rule over here. So sine rule gives us sin A upon A is equal to K. Okay, therefore A is equal to sin A upon K, right? Similarly, sin B upon B is equal to K. Therefore, B is equal to sin B upon K. Let us put this in the sum. So, sin A upon A cos A is equal to sin B, upon K, not A. We substituted A, sin A upon K cos A, sin B upon K cos B. Okay, so K will cancel out. We are left with sin A cos A, sin B cos B. Okay. Now what formula I am using over here? Observe sin B cos B. Okay. So in the brackets I will write sin 2 theta. What is the formula for sin 2 theta? It is 2 sin theta cos theta, right? We have sin theta cos theta. We don't have this 2. So what we can do is we'll put the 2 down over here and use sin theta cos theta formula for these. So we'll have sin of 2a divided by 2 equal to sin of 2b divided by 2, and 2 cancels out. Okay, then we'll take sin 2b on the other side. So sin of 2a minus sin of 2b is equal to 0. We'll use the factorization formula for sin of a minus sin of b. What is the formula for this? We have 2 cos a plus b by 2, right? And sin a minus b by 2, correct? So we are going to use this factorization formula for 2a and 2b. So what the answer will be here is, we'll have 2 cos of 2a plus 2b upon 2, okay, sin of 2a minus 2b upon 2, right? So we are equal to 0 we have, so we cannot put an equal to sign here, right? Okay. Yeah. Now 2 will become 0. 2 inside the brackets will cancel out. So we are left with cos of a plus b and sin of a minus b, okay, equal to 0, right? So what we can write a plus b as now, either you can take cos of a plus b is 0 or sin of a minus b is 0, okay? Or we can do this. What is that? A plus b plus c is equal to 180 degrees, correct? So a plus b will be what? It will be 180 minus c, right? So cos of a plus b, okay, like we have in the question, is equal to cos of 180 minus c. Putting cos on both sides, 180 minus c. Now cos of 180 minus any angle is minus cos of that angle, so minus cos b. So now instead of cos b over here, okay, instead of cos b, I will be putting minus cos c, okay. So minus cos c sin of a minus b is equal to 0. Then we can write minus cos c is equal to 0 or sin of a minus b is equal to 0. So now when is cos angle 0? When cos is pi by 2. So cos of pi by 2 is equal to 0. Okay. And when is sin 0? When sin of 0 is equal to 0. So that means we have c is equal to pi by 2 degrees, or we can say radians over here, or we have a minus b is equal to 0. That says that a is equal to b, right? That means C equal to 90 degrees means either the triangle is a right angle triangle and A equal to B means it is an isosceles triangle. So we can write this as C is equal to 90 degrees. Therefore, triangle ABC is right angled. Okay. Final answer is very important. We have to mention it over here. Triangle ABC is right angled. Okay. Or we can say A is equal to B. Therefore, triangle ABC is an isosceles triangle, right? So this is the conclusion that we get from the sum. Okay. This is our eighth sum. We're left with 4 more questions. Yes, 4 more questions. We'll do it in the next session. If you have any doubts in this session, do let me know. Please write to me, then I would know that. Thank you so much. We'll continue with exercise 3.2, 4 more questions in the next session, and then we'll go to inverse functions. Thank you.